A Falcon 9 upper stage slammed into the moon after drifting for a year, giving orbiters a live view of the impact flash and plume. This is Fascinating Frontiers, episode 153. Scientists verified that the Falcon 9 second stage from the January 2025 lunar lander mission struck the lunar surface on August 5th as orbital models had forecast. The stage had spent more than a year in a high-energy Earth-Moon trajectory before solar activity and gravity pulled it into the moon. Orbiting assets captured the impact flash and resulting plume, providing fresh data on surface composition through ejected material. This event marks one of the few documented cases of an uncontrolled lunar impact by a known spacecraft. SpaceX noted that for lunar transfer missions, nearly all performance goes to payload delivery, so controlled disposal is not always possible. Spectral data from the plume already show sodium and lithium lines, matching earlier ground-based detections of similar events. Now, shifting focus to another European-led effort preparing for the lunar neighborhood. Engineers at Thales Alenia Space in Turin tested the 4 landing legs that will support the ExoMars Rosalind Franklin rover platform in 2030. The legs deploy in 2 sequential pairs using non-explosive actuators in less than 1 second once the front shield separates. Each leg matches the flight article in size and structure and was built by Spain's Sener. The test confirms the mechanism works after months of storage in deep space. Airbus supplies the landing platform while Sener designed and built the legs. Next, teams will integrate the legs with the full landing platform for combined parachute and engine descent trials. On a different note, the James Webb Space Telescope turned its gaze toward a star-forming region in the Carina Nebula. The telescope imaged a cometary globule 7,500 light-years away that contains roughly 70 young stars. The brightest member is an O-type star about 19 times the Sun's mass, and the cluster is estimated at 1.3 million years old. Webb's near-infrared camera penetrated the surrounding dust to show circumstellar disks still embedded around many of the stars. Eta Carinae, 39 light-years northwest on the sky, supplies the intense radiation that helps shape the globule's tail. The treasure chest spans part of the larger 260 light-year Carina Nebula, the nearest high-mass star-forming region in the galaxy. Next up, new solar observations bring fine magnetic details into view from the ground. The latest high-resolution solar image shows fine-scale magnetic structures that appear to drive rapid changes in the Sun's surface. The observation captures instability in the magnetic field on scales smaller than previously resolved from the ground. Researchers are using the data to study how these features contribute to solar flares and coronal heating. The image was released as Astronomy Picture of the Day for August 6th. From solar physics, attention turns to a quantum effect tested in extreme conditions. More than 140 hours of data from NASA's IXPE mission on Magnetar 1E recorded polarization signatures consistent with vacuum birefringence, a long-predicted effect of strong magnetic fields on empty space. The measurement marks the first direct indication of this quantum behavior in an astrophysical setting. Results appear in Nature. While one observatory tests fundamental physics, another maps how gas moves across stellar nurseries. Astronomers mapping the Monosaurus R2 hub filament system found that low-density gas surrounding dense filaments flows inward and replenishes the material available for star formation. Tracking the gas motions showed both direct inflow to the hub and indirect supply to the filaments themselves. In the Monosaurus R2 region, astronomers tracked gas flows across distances comparable to the width of a large terrestrial country, yet the material moves at only a few kilometers per second. Low-density gas that once seemed too thin to matter is now seen streaming inward, both directly toward the central hub and sideways into the dense filaments that already contain most of the star-forming cores. Over roughly 1 million years, this diffuse reservoir can supply enough mass to build stars 10 or more times the Sun's mass without requiring the filaments to grow solely by internal collapse. The measurements come from mapping velocity gradients across the entire hub filament network rather than isolated dense peaks. The finding forces a re-evaluation of how much raw material is truly available in any given stellar nursery. The remaining puzzle is why some hubs convert this extra gas into stars efficiently, while others appear to stall despite similar inflows. Turning now to a nearby super-Earth under fresh scrutiny. Researchers are analyzing new observations of the super-Earth LHS 1140b to assess whether it retains an atmosphere and liquid water. The planet orbits a nearby red dwarf and has been flagged as one of the most promising targets for atmospheric characterization. Further transit spectroscopy is scheduled with current facilities, shifting to an annual sky event visible to many observers. The annual shower has been active since early July and will reach maximum on the night of August 12 into the morning of August 13. Observers worldwide can watch the display under dark skies, with rates expected to remain elevated through the end of August. NASA is providing viewing tips and live coverage. On a different scale, a runaway black hole is revealing past galactic events. The object RBH-1 is racing through space after being ejected from its host galaxy, likely during a past merger event. Its trajectory and speed allow astronomers to reconstruct the dynamics of that earlier collision. Continued monitoring will help map the black hole's path and any remaining bound stars. Next, compact red sources at high redshift are prompting a revised interpretation. James Webb images of compact red objects at high redshift are now being interpreted as possible monster stars rather than galaxies or black holes. Their pulsation properties could explain both their brightness and the formation of early supermassive black holes. Additional spectroscopy is underway to test the model, moving to agency-level agreements that keep crews in orbit. The two agencies will continue swapping seats on Soyuz and Crew Dragon flights to maintain continuous station presence. The new deal does not yet cover Boeing's Starliner spacecraft. Both sides are still discussing how future commercial vehicles might fit into the barter system. From established partnerships, attention shifts to a commercial test issue. Investigators determined that a valve inside the BE-4 engine caused the May static fire failure of the New Glenn rocket. The finding points to a specific component rather than a broader design issue. Engineers are now addressing the valve design before the next test campaign. Finally, one nation is expanding its international reach in space. Government and industry leaders outlined plans to grow international collaboration in satellite manufacturing, launch services, and data applications. The strategy builds on recent successful missions and aims to attract more foreign investment and joint projects. Keep an eye on upcoming combined landing system trials for the ExoMars platform and fresh transit spectroscopy data on LHS 1140b. That's fascinating frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at NERA Network. Links in the show notes. And before you go, this show is part of the NERA Network, a family of daily podcasts on tech, science, and markets, each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Tesla Shorts Time, your daily deep dive into everything Tesla. Find every show free at neranetwork.com. And on the website, every episode's visuals live in our free image gallery at neranetwork.com/gallery. Royalty-free under Creative Commons, download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.